I'm going to show you how I will graph these two functions without using technology. Of course, the purpose is to make sure that you understand the role of those numbers, like here -3, 1, and -2, right? So to graph the first one, I'll begin with x to the fifth. Identify the x to the fifth its parent function, so which is somewhat like this shape, right? Okay, and this is x to the fifth. Now the negative sign and 3, they have different roles here. For 3 you have stretching, so I'm gonna do the 3 you're doing a vertical stretch. So if this is 1, then it becomes 3. If this were 1, this would be 3. If this were say 8, suppose this is 8, it will be 24, way up there, right? So basically I don't care about that much detail. I just want you to make sure that you are doing a vertical stretch. Just think about pulling the two ends up and down by stretching. So this is my 3x to the fifth. Now the negative sign will be flipping. So therefore when you do the negative sign, it's just flipping with respect to the x-axis. So this is mirror image with respect to x-axis. So this will be -3x to the fifth. Okay, now let's talk about this the horizontal shift. Make sure that you know, write this as x minus -1 raised to power 5, right? So therefore you know the horizontal shift is -1, which is to the left 1 unit. So I'm gonna pick another one. So suppose this is 1 unit, then you're gonna shift that to the 1 unit. Okay, shift this blue one to the left 1 unit, and the last one will be the -2. That means you're shifting it down 2 units. I'm almost running out of the color, so the very last one I'll shift the yellow one down 2 units. Okay, so basically this is what it is. Okay, so this is the final one, -3x plus 1 to the fifth minus 2. Okay, so that's the first one. Let's look at the second one. Second one is a little tricky. I absolutely want you to make sure that you write that into a times f of bx minus c plus d, right? So what I'm trying to emphasize is here, this should be the coefficient of x must be 1, and then so that you can correctly identify the horizontal shift. Now so therefore for this particular problem, first thing that I would like to do is factor out the 2 so that coefficient of x is just 1. Okay, and then I distribute the square. This becomes 2 squared, which is 4 times x minus 1 parenthesis square, and then -1. So now I know this is my vertical scale, which is stretch. This is my horizontal shift. This is my vertical shift. So with that, I can begin to graph. So this is the tricky part. It will be wrong. It is wrong to say the horizontal shift is 2. Okay, this is something is 2. This is wrong. This is wrong. Now I'm gonna begin with x squared. So suppose x squared. This is my x squared. Please label your drawing, and then the 4 means I'm gonna stretch this by 4. When it is 1, if this is 1, then it becomes 4. That means that. So this is my x, 4 times x squared. And then after that, I'll do the -1 now. -1 means shift to the right 1 unit. Okay, again, I'm not very care about the detail. I just want to see if so. This is my horizontal shift, And the very last one is my minus 1, so which means shift it down by 1 unit. Okay, and this should be your very last. Okay, 4x minus 1 squared minus 1. So this is it.